morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, Architecting Real-Time AI Systems, Strategies for Handling Dynamic Data at Scale, brought to you by our friends at Tecton. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss how to design AI systems that handle high-velocity, ever-changing data while delivering actionable insights in real time. As organizations rely on instant decision-making to maintain a competitive edge, robust and scalable AI architectures have become essential. In this webinar, we'll explore practical strategies to build AI systems that meet the demands of dynamic data environments at scale. You'll leave with actionable insights to make informed decisions, balance system complexity with performance, and deploy AI systems that drive real-time outcomes. We're honored to hear from a distinguished panel of experts today. Matt Bleifer, Group Product Manager at Tecton, Dr. Francis Boykin, Director of Advanced Analytics at AT&T, and Manisha Goswami, Senior Director of Data Science at Sam's Club is running late, and she may be joining us shortly. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features in the right sidebar. We'll be addressing your questions throughout the webinar, so be sure to upvote the questions you'd like the panel to address. And finally, to learn more about how to architect real-time AI systems, check out the call to action below throughout the webinar from our sponsor, Tecton. Now, without further ado, I'd like to welcome our panel. Welcome, Matt and Francis.
Hey, everybody.
So to kick things off here, why don't we just do some quick introductions? So Francis, why don't you kick us off? I think Francis is running into some connection issues. Matt, why don't you go ahead and we'll come back to Francis.
Hey, everybody. I'm Matt Bleifer. I'm a product manager at Tecton. Tecton is a company that pioneered the concept of a feature store, which has become a critical component in a lot of real-time machine learning systems. Prior to Tecton, I was the product manager for Twitter's machine learning platform. I spent some time there working on things like their home timeline recommendation systems, abuse detection, or ads prediction. And that was really where I had my foray into a lot of this super real-time, high-scale machine learning systems. Before that, I spent a couple of years at Workday, also building out their ML platform and applied applications.
Excellent. Thanks, Matt. Welcome. So why don't we kick things off with our first question. So for those of you who missed it, Francis is Director of Advanced Analytics at AT&T, a longtime friend of DSC. So glad she can join us again. The first question that I want to ask you guys is just kind of the basics of real-time AI and how do you distinguish use cases where real-time AI is absolutely critical to success as opposed to those instances where maybe batch processing or delayed insights are sufficient. So why don't you kick things off for us there, Francis, if we can hear you.
All right. So here I focus on customer experience and focusing on in the world that I'm in is how we can leverage Gen AI customer experience. Looking at is customer insights analysis, chat features, doing that in real time, building out our ability to answer our customers' questions and needs immediately. And that's the big focus, of course, AI, right? Being able to leverage AI to do things quickly and in real time, pretty much, hopefully, before they even know they need them. So we are leveraging it quite a bit just in our data environment.
Excellent. Thanks, Francis. Matt, what do you think about this one?
Yeah, so a lot of what we see on the real-time machine learning application front is things in the fraud detection domain. So, account takeover models, synthetic identity fraud, transaction fraud. Think about customers swiping credit cards. And in real time, models are running to try and make predictions around whether or not something's fraudulent, so they can let that transaction through or block it and go ahead and send a text message. At Twitter, and again with a lot of the customers we work with at Tecton, we see a lot of real-time recommendations. So everyone's had the experience where you're scrolling through these cool social media applications, and suddenly things are updating in real time and seem oddly relevant to everything you're going through. And those experiences are really powered by real-time machine learning systems that are fed by real-time data. We also see things in the world of insurance underwriting, where again, you're taking into account information that users are maybe inputting in real time in order to give a quote for their insurance. So really, like the crux of real-time machine learning is like places where you need real-time data. You can imagine in fraud, it's not enough to be like what happened as of midnight last night if your account's like, in the process of actively getting hacked by somebody. You need to be able to take into account what's actually happening up to the millisecond. And when that's really crucial for your model accuracy, that's when real-time ML comes into play. I do think that there's certainly lots of cases where it's not necessary. If you're doing, maybe churn prediction for customers, this isn't stuff where like, things are changing up to the minute. You can afford to run these models every night. And there's also like product experiences where maybe that's just not what you're going for. So a classic one that I think about is like Spotify's Discover Weekly models, or it's like the product experience you're trying to deliver to a customer is like, hey, every week we give you a new set of song recommendations, and they deliberately want for that product experience people to like have a week to go through and explore it and continue to listen to it. They're not trying to deliver some experience where like, what you were listening to 3 songs ago is now changing what you listen to next. I'm sure that they have those experiences in their product as well. But that's where, it depends on like both what's the product experience you're trying to create, and then how important is the nature of real-time data when it comes to the thing that you're trying to predict.
Yeah, excellent points, Matt. So anything to add there, Francis?
I was just going to add, I love that you really point out that it's a decision that you make based on how quickly do I need to respond to whatever's going on. That's what's going to really determine whether or not you're going to plot, right? We've just in infrastructure and the development of real-time systems, it costs to do that. There's a cost to that. So you need to address our clients. So I like that you focused on that.
Yeah, great point, Francis. So getting into our next question, one of the key themes that we are addressing this year in all of our webinars and our events is the concept of scale. And what works in a POC context or on a very small scale may not work on a large scale. So scalability and is really essential to real-time AI and to AI in general. So what are the most effective strategies or design principles that you've seen or used to build systems that handle massive, high velocity data streams without compromising performance? Matt, why don't you kick that one off?
Yeah, so typically what we see when customers are trying to build pipelines to get real-time data into a machine learning model is there's kind of like one of two approaches. Approach number one is you try to just compute the features in real time. You go to some like, operational online Postgres or MySQL database and just be like, hey, I'm going to run a query and try and get the features immediately. That has some downsides when it comes to latency. So like if at request time you're trying to go run some aggregation that's going to span across like 5 years, maybe you don't have all of that data in your operational database, and B, that might end up like taking a long time and you're going to pay the cost on the latency front. In addition to that, it creates a whole lot of bottlenecks. Technically, you don't typically want like your analytic systems hitting your operational databases that much. It makes it hard for online offline consistency for features, etc. So what we then see is customers tend to mature into more of like a streaming oriented approach, and then they try to use Spark structured streaming or Flink. But the problem there is like now you get into a world of more complex data engineering. You need to think about how you keep those stream processors alive. And again, if they're processing a lot of data, you end up with like huge memory issues that can make it difficult on that side. And it can also be tough to get the level of freshness that you want so that you make sure you're always taking into account like the most recent data. And so both kind of come with their own trade-offs and challenges. One of the things we've worked on and seen pioneered at places like Airbnb is really kind of taking an approach that's a mixture of pre-computing some things and then computing some things at request time with kind of an online store in the middle. So the way that Tecton handles this is if you're trying to compute aggregation value, like what's the user's transaction count over the last 5 years, that's a lot of transactions to process. You want it to be super fresh. You also want it to be low latency. And so what you can actually do is maybe up to midnight, you can be pre-computing, hey, what's their transaction count up until then? And then you can have transactions coming in real time as well, maybe via a stream where you're just maintaining a count of like, hey, what's happened since midnight? And then at request time, that's when you can kind of do the logic to add up all of these partial aggregations. So really like there's some techniques you can employ where you do some things ahead of time and store it in an online store, and then some things at request time, and that can help you kind of balance some of those freshness and latency trade-offs while still kind of keeping the infrastructure and memory footprint low. So there's a lot of tools that do this. Tecton has them built in. We have some cool blogs around it. But that's one of the most effective strategies we've seen for being able to get really, really fresh data that's also available at low latency and doesn't come with huge trade-offs of one of the two approaches I talked about.
Excellent. Thanks, Matt. I see Manisha just joined us. Welcome, Manisha, to the discussion. Joining Matt here from Tecton and Dr. Francis Boykin from Director of Advanced Analytics at AT&T. Francis, I'll give you the word on this question, and then we'll introduce Manisha after that. So go ahead, Francis, if you can tell us how you handle massive data streams without compromising performance.
Yeah, Matt went over quite a bit there, but I think it all kind of rounds out to you have a operating model and culture to support the AI-driven manners in which you want to develop your organization. You have to adopt an ecosystem that need real-time processes, and then focus on a platform-driven approach, but also make sure that you are flexible in that platform as we grow and build out our AI transformation. So I think Matt did a great job. Just wanted to add those three things as well. And I think a lot of our work and time and energy and money honestly goes into rewiring how we do what we do today to support AI. Time or any other
excellent
way.
Absolutely. Excellent points, Francis. And I think you hit on a key theme there, which is, what the way your systems are set up as an enterprise might have been one way in the past. And now if you're trying to retrofit those for AI, there's a lot of changes that need to be made that maybe weren't foreseen at the time that those systems were set up. So that's a very excellent.
Exactly. Yes.
Mm-hmm. Manisha, so if you could, thank you for joining us. I know you're having some network connectivity issues, so glad that you're able to get through those. If you could just give a quick intro to our audience, a little bit more about who you are, what you do at Sam's Club, and then we'd love to get your thoughts on this question as well.
Thank you, Brian. Sorry, I didn't get the question, so you might have to repeat the question for me, but I can quickly start with the introduction. So Manisha Goswami here. I have been with Walmart Inc. for the past almost 10 years, completing 10 years this year. But in my latest role, I am with Sam's Club, which is like the membership arm of Sam's Club, and supporting the data and business insights within Sam's Club, supporting different pillars. I'm primarily responsible for membership and marketing and some of the AI initiatives that we are starting, or not just from Gen AI perspective, which are more on the innovative stage, but AI, which is more matured, right? A broader AI ML framework, I would say, that is more matured there. So that's my role, primarily leading teams which do that work.
Excellent. Thanks, Manisha. Thanks for joining us. And the question that we were just speaking to was around the concept of scalability. So what are the most effective strategies or design principles that you've seen to build systems that handle massive, high velocity data streams without compromising performance?
Yeah, I think some of the things that we are dealing with in terms of like recently what I'm dealing with is on member data that we are creating, and which has like large amounts of data for our active as well as inactive members. And how do we first put it up? I mean, optimize that data itself. I think that would be one thing, making sure that we are creating our data elements in a way that if the data itself needs to be accessible in real time, that data should be at a place where it's faster accessible, and the ones that don't need to be are not part of that data element, because that's what we're struggling with today. But in general, if I talk about at a higher level, I think one thing I'll go with is distributed computing, which is important in terms of scalability, right? Having that parallel processing capabilities within your framework and build the architecture that way. The other piece I would think about in terms of scalability is going to the point where which data needs to be at your finger point and which does not need to be. So kind of that stream processing architecture in terms of that establishes that, right? That establishes that framework. I think those would be a couple of important things. And then some of the other elementary things are like having the data storage itself, which is scalable. And I already talked about efficient data handling, which goes into scalability a lot.
Yeah, great points, Manisha. So in addition to the question of scale, there's also the question of dynamic data flows, which is different but related. So real-time systems, of course, need to handle ever-changing data patterns. So how do you design resilient data pipelines that can adapt to evolving data while maintaining the accuracy and reliability? Francis, why don't you speak to that one?
Absolutely. So I think I want to go back to the conversation we just had about the ecosystem. So building out your ecosystem, increasing your relevance to the global sustainability of across your organization for the life cycle procedures that you need for sustaining your AI transformation. So for me, it's really about leveraging how you build in order to be able to quickly make the changes and implement what's needed to sustain what you're trying to deliver on a day-to-day basis.
Yeah, great
And
point.
that is all, it's all encompassing. Yes. Yeah, it's all encompassing, and it touches every organization. And what one thing that we're finding out here at AT&T is that it takes our entire village. So it takes all of us in all of our different capacities to bring this all to fruition. And I want to add this, and I won't say that this happened at AT&T. I'm just saying that this might happen. Wink, wink, nudge, nudge. But one of the things that when we started out first with, oh my gosh, here's this groups, these special groups, we might as well have put lab coats on them, right? And said, these special people over here are doing AI. And what we have learned over the past 3 to 4 years, is that, yes, that brain store that you have is great, but you've got to disseminate that information across your organization, and everybody's got to be involved if you're going to make this resilient, sustainable, and useful long term. So that's one of the things that I will say as well.
Yeah, excellent points, Francis. Manisha, what are you seeing in terms of managing dynamic data flows?
So I think one thing that I know Francis touched upon is the CI/CD pipelines, which are very crucial, right? Ensure that those updates and improvements can be deployed quickly and safely. The other piece I would say is also around having those alerts in real time, that you are monitoring those systems, right? To build that accuracy and reliability and resilience that you talked about. It's and it also, I think, a couple of things that we are building here require us to be sending some of these, and this is more in terms of surveys that we do for our members and how we do them and how these data is sent out and the surveys are sent out. At times we are missing the lags because we don't have resources to monitor these systems, right? So how can we build those systems which in real time monitor that the things are flowing correctly and the outputs that are needed to be generated are being generated? So we are very, I think, conscious about how do we put those real-time monitoring and alerts so that we do not have to have a person in place to do these, but sure that this ran through. But if there are any challenges that happen, there is a fallback, how many times can we run it, and things like that. So I think that helps a lot in creating those resilient systems and what is the fallback plan there. And I think in terms of, I think those are the few things that I think about in terms of what we can do, but the architecture itself should also support it. I think that's also important, right? The framework should be scalable as well as modular to support these resilience.
Yeah, great points, Manisha. Matt?
Building on to what Manisha said, a lot of this comes down to monitoring and alerting. And I kind of think of this in like two different camps. One is like system level monitoring. So obviously you want to be like, checking for job health, but you also want to be checking for like, what's the throughput of your streaming pipelines? What's the freshness of the data that's coming through? How quickly are you able to like process it and get it to some online store that you're going to read it from? How stale is your data? When's the last like event that you processed, et cetera? So a lot of this is like kind of looking at like the health of the overall data pipeline. And then I also think that data quality validations and data drift detection becomes really important in these systems as well. So you want to have things in place so you can understand like, hey, do I have a pipeline that's just, mysteriously gone to zero or giving me all nulls? That's certainly going to destroy your model quality. And one of the tricky things that you always find in these systems is that models tend to fail silently. So if some data pipeline breaks and it starts, writing out a bunch of nulls, you might see model quality drop, but that can kind of be like a lagging indicator. You don't realize necessarily that something's wrong in the same way you would if there's like a bug in a normal production software application and no one can load their homepage in their application. And so having kind of monitoring on these data pipelines in real time can help you catch those issues much sooner. And then, as I was saying, drift detection becomes really important too, because the state of the world changes over time. And so if, the underlying data that's powering a particular feature for a model is shifting, or in particular is different than what you trained on, then your model quality is going to go down. And so it's important that you also have systems in place to be able to monitor how is the distribution of my data changing over time, and how is it changing relative to what I had at the time of training.
Yeah, great points, Matt. Francis, I know you need to run in a second. I wanted to just get your thoughts on this question. Strategies to optimize efficiency while delivering real-time responsiveness. So how do you handle situations where operational costs and performance trade-offs are critical concerns? What are the strategies that you use to balance those two things?
Yes, great question. I don't think we've talked in high types of deployments for our leveraging the ability to be quickly between well. But I also think that we haven't talked about the fact that as we start looking at within building out an optimized return on investment for our right. So you've built out this. So what are the use cases that you can use that best leverage what you have? So sometimes it's about optimizing with what you have, and then other times it's about building out new. But of course, building out new costs additional funds, right? So you've got to have the budget and that sort of thing. So there's a balance there that I know that we have done at AT&T between what projects we're willing to implement versus our architecture and our architecture build out and our transformation. So building that balance is what has allowed us to move forward. And I think that in 2025, we're in 2024, just because we've started to leverage those kinds of, okay.
Yep. Thanks, Francis. And we're cutting out a little bit there, but I caught most of the gist of what you said, which was that, you have to choose as an organization, right? You have what you have, right? And so it's nice to say, well, here's all the things that we would love to have and all the use cases that we would love to work on. But at the end of the day, as an organization, especially a large enterprise, you have what you have. And so you have to start there. And that's a critical part of the equation, is figuring out how do we do the best we can with what we have, and what are some of the low-hanging fruit use cases that we can deploy in light of that current infrastructure. So great contributions there, Francis. Matt, do you want to take that one next?
Sure. Sorry, the question was around optimizing system efficiency.
Yeah, balancing efficiency and cost with the need to have real-time responsiveness.
Yeah, so I think there's a couple strategies you can employ here. Obviously there's technical strategies that can help, things like, having good caching for online features that might be expensive to compute. There's other technical things we've employed, using simple features that you'll find offered on AWS, where you can bulk load S3 tables to an online store at a fraction of the price it would take you to be able to write all of those rows individually. So there's a whole world of kind of technical improvements that you can invest in. Some of the other things that we've seen really valuable for people, though, one is, especially as you scale your organization, you'll find that features can often be reused across many different use cases, but without the right kind of both organizational structures in place and also product capabilities in place, it can be difficult to actually reuse a lot of your feature pipelines. And so instead, what we find is team A, B, C, and D are all reinventing the wheel over and over. And that's additional cost you're paying that doesn't need to be paid in order to keep computing, the same things on the same entities. So feature reuse can be an effective strategy for driving down costs. Another one that we find is, if you have clear tracking of the consumers of these data pipelines, then you can start to understand A, what's the ROI of any given feature that you're producing. So hey, if I'm building something that's used in 10 different use cases or queried quite often, That can be an indicator that it's a useful pipeline. And on the flip side, you'd be surprised how often people are running some expensive data pipeline that is no longer actually being consumed. They moved on to some V2, they never turned off the old one. And so, there's a lot of waste going around. And so having systems in place that again can kind of flag that, like, hey, this thing's computing super real-time data and then never getting requested out the other end. If you have that full lineage, that can be really helpful. And then honestly, even just like basic tagging, like ensuring that you have tagging all the way down to the underlying infrastructure that you're using, so you can always do some kind of cost analysis and figure out, like, hey, of all the resources that it's taking me in order to compute this feature, like, what's the total cost for this? And then, if you want to go really deep, I think you can do some more like analysis of, like, what's the incremental benefit that I get from any given feature I'm adding to a model across all my models, and then what's the cost that I'm paying for this thing. So yeah, those are some of the things that I think come to mind for me.
Yeah, great points, Matt. Manisha, what are your thoughts? How do you balance cost and efficiency with real-time responsiveness?
Well, I think Matt covered quite a few of them. I think balancing this, I mean, how do you optimize system efficiency? Think it's kind of involves balancing performance and cost, right? So, I mean, how much am I willing to pay for what kind of performance do I want? And I think the first thing to assess is what is the use case for real-time responsiveness, right? Does this actually, do you need for which cases actually demand real-time responsiveness, right? That we should be very, I'd say, consciously decide what are those use cases. And once we have decided, I think the few things that Matt also touched upon, like one could be model optimization, right? Which features do we want to run through? Do we want a whole plethora of things, or there are things that we want to work on? I think a knowledge distillation is used a lot today as well, built upon, like, train on smaller, faster models, and then that may make a larger one that actually also helps you reduce some of the cost and go faster. I think Matt also touched upon having efficient data handling, right? Making sure that we have the right real-time data filtering systems and we are not like training or building on anything or everything, right? That's also important. And going back to the model optimization, I'll also say having efficient algorithms to choose from and work through for these real-time processing systems. And then after that, it's also about monitoring and alerting that we talked for the previous question. It is also important here. Those are a few things come to my mind.
Yeah, great points. And I want to get to a couple of questions that have popped up in the chat that are relevant to some of the topics that we've addressed already. This question, how do you handle, from Wasim, how do you handle data quality within a real-time system? So specifically the data quality of this, how do you tackle that? Matt or Manisha, you want to speak to that?
Yeah, I'm happy to dig in. So I talked a little bit about like what things you might want to monitor, but I think that when it comes to data quality, most of the architecture comes down to like logging what you're getting in real time. So like, logging at some place the features that are being produced by your stream processor, or logging like the feature vectors that you're getting returned in real time. And then at that point, once you have like, hey, I have a log of everything that I've seen in the last day in production, and I also have, my training data set. I think that's where you can then just run some offline jobs and, set up some Airflow job that goes through and just, computes differences in distributions between the logs of what you're seeing online and what you're seeing offline. Usually that like day level granularity is good enough when it comes to analyzing things like drift, and you don't necessarily need like the super real time monitoring, but you do want to definitely monitor data in real time. If you're seeing like a feature pipeline that's consistently going to zero, that can be helpful to have some more like online monitoring systems for. But I would in most cases start simple with these things, log the data and run like hourly or daily jobs on it.
Yeah, great points, Matt. Manisha, anything to add there?
No, I think Matt touched upon like that. When do you monitor and what do you monitor and to what extent? But I would, depending on again which real-time system and how much can you control, right? What is being flowed through? Can you build balances and checks when you're building the systems? For example, there is a chatbot we are trying to build for our clubs, and we are testing right now internally what kind of data it is producing and how much does it hallucinate, right? And how we can build some checks on it that it does not do that. How many times it can, and trying to think how many times does it do that, and how do we do those checks on top of it, as well as can we have that prompt questions that it does not do that, right? I mean, it is not going to help. And I'm talking specifically on the Gen AI use case here, but the main theme here is, can we build some of these data quality checks in the system, in the real-time system while we are building it, so that we are to some extent or 90% more accurate results are coming out of it, right? To some extent, we can assure that. And then go back and look at the logs, as Matt said, when we are monitoring it in real time and how we can improve upon it. But I feel that there is an element before we implement these systems, and then after we have implemented, how do we keep those checks and balances?
Yeah, great points, Manisha. And Anurag has a bit of a follow-up to that. So we've talked a bit about model drift. What are the actions specifically that you can take if the model is drifting significantly? So we talk about some needing to look out for model drift, but then what do you do when that occurs? So Manisha or Matt, any thoughts there?
Yeah, I think simple answer is retrain your model. I think it's generally a good practice, if possible, to set up automated model retraining so that maybe every day or every week have some pipeline that's going through and training on the latest data that you've seen, and publish that to production, compare it to the current model, etc. But in most cases, I think if you're seeing some distribution shift between the data that you trained on and the data that you're seeing in production, it's just a good sign to retrain your model.
Yeah, I think I agree with Matt. Usually that's the solution. But the other thing we also try to do is have periodic retraining as it is, right? And making sure we also are monitoring how the model is performing at a regular basis. So it should not be an afterthought. I think it should be part of model production that we are, what do you say, monitoring it at the same time and making sure if we see any drifting, we are retraining it, but then also have a schedule to retrain no matter what.
Yeah, great points. One of the other follow-ups we had in the chat is from Marshall. To connect this data pipeline discussion with AI, can you please explicitly specify the particular AI model or model architecture involved in practice? Of course, there are numerous options to choose from, but I guess what have you guys seen in terms of the models or architectures that are out there? What has worked best in the real-time AI context?
Can we, I'm trying to understand the question more, like when we talk about architecture, are we talking about how we are productionizing these systems? There is a data architecture, data pipelining that goes into it. And then there is how do we deploy the models? I'm trying to understand the question more clearly.
Yeah, I think earlier we had mentioned about the need to have resilient data pipelines that can adapt to evolving data that's real time and that maintains accuracy and reliability in light of that ever-changing data patterns. So I think this was a follow-up to that, asking specifically.
Okay.
Right. What and Marshall looks like just added ChatGPT, voxel, time series. So I think he's just wondering what are you actually using in practice in terms of the models?
I can give one example of how we are building some of the AI models, and Gen AI is a subset of it, but I'll talk more from the traditional AI perspective and then can give an example on Gen AI. But from AI perspective, our goal is not to go into data pipelining. So we want to use standardized or centralized data sources that are being available to us. And we are working towards that as well, right? Making sure our data is taken care of. We are having a centralized truth, one source of truth that it comes from. So that's where our engineering teams work towards that. They have a continuous flow of data in real time that it gets updated, right? So when we build the systems that read through that data, we are ensuring that the data is being taken care of, and we are relying on our engineering sources to do that. So they go to the system of records to get the data into these sources that then we can tap into, which is like we're also building a feature store out of it so that we are not also doing feature engineering on top of this data. So that's a centralized place. And I think that works well to build an AI. And so it takes the data science team out of these engineering pipelines when that has been taken care of at a centralized level. And I think that is working well for our systems. And then for specifically within Walmart world, we have different use cases of productionizing the data models, one of them, we have our own platform, which allows us to create these different elements through a different programming framework. And then it allows us to actually schedule jobs, do batch runs and all that, and create outputs and save it on the cloud. So we have an infrastructure already built that can help us productionize these systems faster. So what I've seen in practice is having those centralized systems for data that take care of the data, making sure that the reliability of data is accounted for from that team, going from the system of records, which ensures that the data is being updated in near real time or real time as needed. And then the system itself or the infrastructure itself allows us to productionize the data models quickly.
Yeah, great points, Manisha. Matt?
Yeah, most of what we see when it comes to real-time ML systems is still maybe what I'll call, Gen 1 of ML, where we see a lot of classification modeling. So to anchor it to use cases, right, there's, maybe fraud detection systems that are classifying a transaction as fraudulent or not, or a recommendation system that's trying to classify like, hey, is Brian likely to click on a particular tweet or not? And you use that to be able to rank a timeline. And specifically what people use there, it ranges, logistic regression models, decision trees. It could be like scikit-learn, XGBoost, et cetera, TensorFlow or PyTorch for more advanced deep learning models there, et cetera. But I think there's also like kind of a question baked in here maybe of like, hey, how does like Gen AI fit into the mix of all of these real-time data pipelines? And we've seen some interesting use cases with customers that kind of like merge the intersection of both the real-time data and these Gen AI models. One example I'll give is we work with a customer that's building out your standard like support chatbot based off of latest OpenAI model, but they need to be able to get context to that LLM that includes things like, hey, what support tickets has the user filed recently? What were they recently doing on the application? What's the status of their support ticket? All of that is like necessary context. You can almost think of it in a way as like, it is like retrieval augmented generation, but not in the typical sense we usually talk about it, where, we run some offline process to create a bunch of embeddings of documents that we're going to go look up later. That use case is not inherently as like real time, but I have seen in the support use case, like you really do need the real time context to feed into these models so that they know like, how do I even properly respond to this user question? So I think that's been one of the cases that's been kind of a cool intersection. And then we've actually also seen cases where now customers are using LLMs to do feature transformations even in real time. So maybe you have like some unstructured text that's coming through, maybe like an email or something. And now you can just send that to an OpenAI API, and along with like some prompt that's like, hey, I need you to extract like, the named entities inside of this, or I need you to like analyze the tone of this thing. So I think that can also be like kind of an interesting intersection between like these real-time data pipelines that typically have fed into like standard classification models, but now are getting infused a lot more with Gen AI.
Yeah, great points. So to shift gears just a little bit, obviously with AI continuing to develop, one of the things that we've seen is the need to reskill workforces, and that there are many different skill sets and tools and roles that are evolving as AI continues to grow in significance, and real-time AI specifically. So as we continue in the next 2 to 5 years to grow AI and real-time AI, what do you guys see as the most critical skills, tools, and roles for organizations that are going to need to deploy these technologies? Matt, why don't you start that one?
Yeah, I think that like what we increasingly see is kind of a blend between the worlds of data science and software engineering. And now the barrier to entry for putting AI into an application is lower than ever, because suddenly we can just start hitting Anthropic and OpenAI APIs and putting that directly into our use case. But still, even when you talk about a lot of these more like classical high value models for fraud detection or recommendation systems, like a lot of this sits at the intersection of software engineering and data science. And I think the most valuable folks we see in the process tend to be the ones that can kind of merge those worlds effectively, that have like a little bit of the data science skills, a little bit of the data engineering, and a little bit of the software engineering. And I don't think that means like your whole team has to consist of those people, but a given team needs to be able to span across those use cases. Like you need people that are good at the data and the data science, you need people that are good at the data engineering, and you need people that are good at the software engineering. I think the more that you can kind of like spread some skills across that, that's going to continue to be important as we see an increase both in the like operationalization of kind of these classical use cases as well as the integration of these more Gen AI centric use cases.
Yeah, great points, Matt. Manisha, what are you seeing?
Yeah, I think some of those roles are like crossing boundaries. Matt spoke to a few of those, but in my area of work, I see a lot more, I think, ask of also how do we get business context into some of these models and solutions that we are building and generate those insights that make sense, right? That can drive action. So that's a discussion that we are having internally, that with all this new ways of building models, delivering models, or getting some of the insights, how do we make sense of it, and how do these some of these roles evolve to make sense of what is being generated, right? So I think that would be a new skill set. I would believe that some of the data scientists or analysts would have to develop, that we're not just building things in silo, looking at the data and creating these models, but also how do we then interpret them, explain them, and then bring some actionable insights out of it. But I still think that some of those traditional roles will remain, but I think those roles have to evolve. Some of them will have to evolve in terms of how do you also wrap those business context around it.
Yeah, excellent points. And what I'm hearing from both of you is the importance of cross-functional teams that have a variety of different technical expertise and business insights, business background, and then also having cross-functional skill sets, even for each individual, being able to understand the entire picture and having at least a little bit of expertise in a variety of different areas to kind of put the whole puzzle together. So I think those are great insights there. We've got one more question here in the chat, and this is a couple of questions from Johan around specific tools. So Johan asked, are you mainly building LSTM, CNNs, or transformers? What are you using for time series data, tabular data, etc.? And then has everyone switched to PyTorch, or is anyone still using TensorFlow? So you guys want to weigh in on what you're seeing on some specific tools?
In my area, almost, I mean, still those traditional tools are still being used. I think one of the things that we are trying to use more of is the Gen AI, right? Trying to see where all can we bring these new, and even there, I mean, we are looking at different LLM models as well. I mean, it's not just one that we are trying to explore. So all those traditional programming languages or packages are still being utilized in our area, depending on, but I'd still say TensorFlow, PyTorch, all those are still being heavily utilized. I think the other ones, the older ones, have taken a backseat, I would say. Yeah.
Thanks, Manisha. Matt, what are you seeing?
Yeah, so again, most of what we see is still focused more on like kind of classification use cases where, what we're saying is like, maybe deep learning, maybe simple logistic regression models or decision trees. For customers who are working on more Gen AI use cases, usually it's all transformer centric, but I don't think we see as many people like building transformers from scratch. Obviously, they're either just going and hitting one of these like model provider APIs, OpenAI, Anthropic, Google, etc., or doing the same thing through something like Amazon Bedrock, or we see people fine-tuning open source models to be a little bit more catered to the data that they're seeing and the ways that they want it to respond.
Yeah, great points, Matt. So we're just about out of time, so I want to wrap things up with our lightning round. If you could, in one phrase or a couple, provide your key takeaway for building robust real-time AI systems. What's the one thing you want to leave our audience with today? Matt, why don't you start with that one?
I think the key takeaway I would say is like investing in your infrastructure. I think things go south really quick when you try to keep the whole bespoke pipeline thing going for too long. You end up with this kind of like nightmare web of data and consumers and data pipelines, and it just quickly breaks down and becomes really tough to manage. So whether it's like building something in-house, taking an off-the-shelf vendor, whatever makes the most sense for your organization. I think really investing upfront in your ML platform and your ML infrastructure can help pay a lot of dividends as you go downstream.
Yeah, great points, Matt. And Manisha, we'll give you the final word.
I think I would say that invest in the data, quality and how the data itself, data architecture itself is built, that is very important, because whatever goes in, it comes out, right? So in my time within Walmart, I think investing in data has given us, I think, good dividends, making sure that we are building reliable data systems. Then we can talk a lot about like how do we build our AI modeling structure or Gen AI modeling structure. Those are the things that can be built upon it. But one key takeaway for me would be having the right data.
Yeah, great points, Manisha. We say around here that the best AI strategy is a good data strategy. So makes a lot of sense. So I want to say special thank you to all of our panelists today, Matt, Manisha, and Francis. Appreciate everyone in the audience for joining us today and all the great insights that we heard today. If you missed any of the webinar or want to rewatch anything, the recording will be available just a few minutes after the webinar if you refresh this page. We'll also be sending out an email tomorrow with the recording, and it will be available on our YouTube channel starting tomorrow as well. I want to say a special thank you again to our partners at Tecton for making this webinar possible, and we'll see all of you again next time. Thanks.